Greetings to all the viewers. The session is going to cover with the natural product in that we completed with alkaloids. Now we entered into another segment called the terpenoids. In the terpenoids, what is the introduction? What kind of categorization is possible, and how can we generate various kind of terpenoids? That isoprene rule entire topics was covered in the earlier session. We are now considering individual terpenoids, in what way they exist in the nature, from which kind of plants we are able to extract, and later on how the biosynthesis of these terpenoids are possible within the plant materials, and is it possible to synthesize the same material alternatively in the laboratory pathway? What significance we have, potential applications of that kind of compounds are taken into the consideration. Today's topic is about camphor. Camphor is the natural product. It is the part of terpenoid, and this is the camphor tree you can observe over here. And the crystals, whichever available in the white color, these are called the camphor. And this is kind of being all terpenoids are essential oils. We can extract camphor oil from this kind of plant material and these crystals as well. Let's delve into today's session. Before entering, one more thing we have to insist over here. The entire session is powered by AI. AI powered session we are going to discuss about. Let's enter into our today's session. Camphor is naturally occurring organic compound with the chemical formula C10H16O. Here, if you observe camphor organic compound, it will be all carbon hydrogens are involved in the formation. And the C10H16O, isoprene is of C5 unit, so that when two isoprene units are going to be combined, it is the kind of isoprene. So monoterpene we can say. When two isoprenes combined, that is called monoterpene, and being it is a cyclic compound, cyclic monoterpene compound it will be. It is a terpenoid and a white crystalline substance. If you observe, it is the crystalline nature and exists in white in color. Strong aromatic odor will be there. A distinctive or characteristic odor, that is the main reason this camphor having the significance in the spiritual plethora, right? Camphor is widely used in the various industries and applications due to its unique properties. And another important property we can say it is sublimated. Any material we are heating, that solid will be turned into liquid, right? Liquid further heated, that liquid turned into a vapor. So that is the kind of series or sequence you can notice. But whenever we are burning the camphor, directly it will be turned into a gas without any liquid formation. That is called a sublimation. Camphor having that unique property. In addition to this one, other properties also present for this camphor terpenoid. Sources of camphor naturally derived from the camphor tree. Just now we saw camphor tree will be there. These are the seeds from which we are able to extract, and its scientific name is designated as Cinnamomum camphora. Let me repeat. Cinnamomum camphora is the scientific name of the camphor tree. It is the native of Asia. In the Asia continent, we can observe such kind of camphor trees. Synthetic camphor is produced industrially from alpha-pinene. Alpha-pinene is a precursor. Earlier session, we covered the entire history of alpha-pinene. Alpha-pinene is the precursor from which camphor can be synthesized within the laboratory, right? So, a compound found in the turpentine oil. Everybody aware about turpentine oil, varnish, all these are the solvents utilized in the painting or adhesives, right? So, this is about what? From where we are able to extract the camphor. Now, some properties are mentioned over physical and chemical properties of camphor. Molecular formula is mentioned as C10H16O. Oxygenated hydrocarbon it will be. And two isoprene units are combined so that it is the monoterpene. If you observe, one 6-membered ring will be there. Another 1, 2, 3, 4, 5-membered ring is also there. That is a condensed one. So this is the kind of molecular formula it able to exhibit. Molecular mass. weight of the substance will be 152.23 gram per mole. 1 mole of the substance is comprising 152.23 grams. Appearance, white crystalline solid. If you observe camphor, it is in white color, right? Melting point, it able to melt. That solid will be melted at the temperature 175 to 177 degrees centigrade. Boiling is very rare. 204 degrees centigrade boiling from liquid to vaporization is possible. So this is the important property. A strong pungent characteristic odor or smell is given for this camphor. That's the reason why it is having perfumery as well as this spiritual applications. So in most of the cases we are giving arti, that is with this what camphor only, right? And if you observe clearly within the nature, R plus camphor, S minus camphor, both are possible, right? Absolute configuration is designated as R and S. Both the isomers are available. Plus and minus forms are enantiomeric forms. Plus denotes a dextroisomer, minus denotes a levoisomer. Both the isomers are possible, both the configurations also possible for this kind of camphor. This is the kind of isomerism or else orientation of the functional groups within the molecule, right? Now we entered into another segment which is called applications of camphor. This is the most important segment. Applications, medicinal uses. Used as a topical analgesic for pain relief. What kind of pain it might be, we can apply this camphor as a powdered form so that it used to relieve the pains. So pain relieving tendency is the common medicinal application for this camphor. Common in the balms, ointments and liniments to relieve the pains, and also not only pains but also cough, congestion and muscle pains can be, right? So if you observe clearly here, cough conditions can be mitigated. Being it is a kind of volatile material, we can easily inhale, or else in the form of bombs, we can apply externally. Ointments, just like a gel form, it is available in the market. So liniments, so liniment trade material is also available. Either of the thing can be applied externally in order to mitigate or in order to reduce the cough conditions. Congestion is also a nasal disorder. Muscle pains, whatever muscle pains we have, that also regulated by means of this muscular pains also relieved by means of this camphor. Anti-inflammatory and antimicrobial properties. Anti-inflammatory is nothing but inflammation in the sense whenever we are experiencing the joint pain, especially because of lack of synovial fluid in between. That is a kind of lubricant which used to slide one bone upon another, that used to avoid the friction in between the bone, so that joint pains are not possible. Whenever synovial fluid is not there, direct rubbing of the bones which used to induce the severe pain wherever joints are present, that is also the kind of inflammation. Wherever such a direct bone friction is possible, there is a possibility for this inflammations. Such conditions also mitigated or minimized by means of camphor. Antimicrobial property. Microbes are nothing but which are tiny in nature, invisible in nature. Under microscopic examination only we are able to see them. They are able to induce millions of diseases into the human and also other living organisms as well. They might be bacteria, virus, fungi, algae, any kind of material. All these type of symptoms or diseases get curated by means of camphor, so that we can conveniently say antimicrobial properties also imparted for this camphor. Now we entered into another application called industrial usage, right? In the manufacturing of plastics, being it is made up of what? Isoprene units, so that it is a precursor for synthesizing so many kind of plastic materials, especially celluloid. Celluloid type of polymers can be fabricated or manufactured starting from this camphor, and these celluloids are utilized in these photography film manufacturing, right? Used as a insect repellent and fumigant. Insect repellent means when we are spraying this kind of camphor in our surrounding vicinity, that pungent smell used to repel the insects, that used to avoid the insects, so that insect repelling tendency will be there for this camphor. Fumigant is nothing but by fuming or by spraying these fumes, camphor fumes, what happens? Whatever pests are there on the plants or else any conditions, we can conveniently retard them. We can conveniently remove them. That is called fumigant agent. Camphor can be powdered and can be evaporated. Those vapors are those kind of foam. Fumes can be sprayed on the plants or else crop plants, so that we can remove the pests which are causing diseases and reduce the crop yield in the croplands. And most important, we can say religious and cultural significance. Everybody aware about Ganga Aarti and Godavari Aarti as well, where we are praying water, we are praying goddess water, because that is the lifeline for all kind of civilizations. That's the reason why here the photography which is related with Ganga Aarti is provided, where we are consuming this camphor for the spiritual prayer, right? Because the application is purely because a fragrant smoke is generated by the combustion of this material. That's the reason why religious and cultural significance wherever we are praying, so we will give the aarti to the god at the end of that puja, right? So that time we are burning these camphor crystals, so that is because of its fragrant smoke. While combustion, it used to release whatever smoke is coming, that used to curate so many kind of diseases as well. That's the reason why it is a kind of medicinal impact in the rituals, right? Any other applications are it is the ingredient in the perfumes, being it is the essential oil, so that it is a part of perfumes as well. And cosmetics, so many cosmetics also, it is incorporated flavoring agent, just like all the remaining, like lemon, chilies and vinegar, everything we are going to add in order to improve the taste. In a similar manner, camphor is also the part of that food or kitchen ingredient which used to enhance the flavor of that what dishes. Now we entered into another part called biosynthesis of camphor. Biosynthesis means camphor is generated within the plant material. Then what is the path? What is the mechanism for the synthesis of that camphor within the plant material, that we are going to discuss. Biosynthesis of camphor involves the production of plants through metabolic pathway, monoterpene, as already we aware, camphor is a monoterpene material. It is a subclass of terpenoid. Monoterpene and the terpenoid class material it will be, and derived from the isoprene units. Two isoprene units are going to be combined, so that monoterpene will be generated. Camphor is synthesized in the plants such as a camphor tree. Just now we saw camphor tree, right? Cinnamomum camphora is the scientific name of that camphor tree, and some other species like rosemary and sage. So rosemary plants are available over here, and sage plant is also there. They also used to give the certain extent of this camphor, right? Cinnamon camphora is the economic plant from which the maximum extent of camphor will be extracted. Now, we are discussing the detailed biosynthesis of this camphor. The steps involved in the biosynthesis are going to be discussed over here. Formation of isoprene unit. Sorry, isopentenyl pyrophosphate (IPP) is the precursor for this one. and dimethyl allyl pyrophosphate DMAPP are produced via mevalonic acid pathway or else MEP pathway. Either of the pathway can be applied in order to synthesize isopentenyl pyrophosphate and dimethyl allyl pyrophosphate. These are the starting materials in order to synthesize the camphor. Whenever we are synthesizing these materials, next step is to generate GPP. GPP stands for geranyl pyrophosphate. In order to prepare geranyl pyrophosphate, IPP, that is isopentenyl pyrophosphate, and dimethyl allyl pyrophosphate, both are used to condense. Condensation is nothing but when two chemical components are added, small molecules like water or else any carbon dioxide, small molecules will be removed and both are able to condense. So that IPP and DMAPP are able to condense to form geranyl pyrophosphate. This is the important key intermediate over here. Geranyl pyrophosphate will be generated. From this geranyl pyrophosphate, we synthesized alpha pinene, right? In a similar manner, geranyl pyrophosphate are universal precursor for monoterpenoids. Just now we say not only camphor, not only alpha-pinene, most of the monoterpenes can be synthesized from this geranyl pyrophosphate. It is the key intermediate for most of the monoterpenes, right? Cyclization to bornyl pyrophosphate. Here is the certain amount of change in the path of synthesis. Alpha pinene can be geranyl pyrophosphate when added with pinene synthase so that alpha pinene will be synthesized. Now we have to go for the GPP reaction with bornyl pyrophosphate synthase. This is another enzyme we are going to apply so that GPP undergoes cyclization reaction because here distinctive enzyme is going to operate bornyl pyrophosphate synthase. Whenever bornyl pyrophosphate synthase is working on GPP, this geranyl pyrophosphate now turned into bornyl pyrophosphate. This bornyl pyrophosphate is the most important bicyclic monoterpene intermediate here. Okay. It is the route map for the mevalonic acid synthesis because the mechanism proceeded with mevalonic acid. The starting material will be acetyl coenzyme A. Later on, its chemical composition is provided. Later on, it will go for the reduction. NADPH is the reducing agent. Wherever this kind of ketonic group is there, that able to attached with the hydrogen so that O minus oxide will be generated. Later on, we have to condense back this negative charge, delocalize the negative charge in order to receive the double bond, and subsequently SOCA will be removed and aldehyde will be generated. Later on, again another reducing agent NADPH will be added, aldehyde will be turned into a alcohol. That alcohol form, here we have a ester kind of linkage, can be hydrolyzed. Subsequently, we are able to achieve the most important chemical that is called mevalonic acid synthesis is possible because the mechanism our biosynthesis is proceeded via mevalonic acid. That's why we have to aware about how the mevalonic acid will be synthesized. After getting this mevalonic acid, further transformation giving rise to IPP. Isopentenyl pyrophosphate is the IPP. This IPP, another isomeric form will be there, that is the DMAPP. Both are isomeric in nature. These are able to condense. We are able to get GPP, geranyl pyrophosphate. Sorry, geranyl pyrophosphate can be reacted with bornyl pyrophosphate synthase. Bornyl pyrophosphate synthase. This is the enzyme to be operated so that GPP now turned into bornyl pyrophosphate, that is called BPP. Bornyl pyrophosphate is the bicyclic intermediate for the synthesis of camphor. Now, the entire route map is provided for the quick understanding. After getting that bornyl pyrophosphate, now we have to go for borneol. Another chemical step is borneol synthesis. In order to synthesize bornyl pyrophosphate to be hydrolyzed. Whenever hydrolysis is possible, borneol will be generated. After getting borneol, only one step is left, that borneol to be oxidized. Borneol dehydrogenase. Borneol dehydrogenase. What is the difference? What is the similarity between dehydrogenase and oxidation? So oxidation can be defined in various methods. Addition of oxygen is the oxidation, or else removal of hydrogen is also oxidation. Here, Borneol dehydrogenase stands for hydrogen removal. Hydrogen removal is also defined as oxidation. That's the reason why Borneol oxidized into a camphor by the removal of hydrogen, so that oxidation is possible. Let me show the entire route map for the synthesis of camphor by means of mevalonic acid pathway. IPP stands for isopentenyl pyrophosphate, dimethyl allyl pyrophosphate. Both are able to condense, so that we will get a key intermediate called GPP. GPP is the precursor for so many kind of monoterpenoids, as already we know that. Let me go with the required pathway. So this GPP to be added with BPPS. So bornyl pyrophosphate synthase to be added. So that GPP is transformed into BPP. BPP stands for what? Bornyl pyrophosphate. This bornyl pyrophosphate is converted into borneol. What to be added? Hydrolysis. Hydrolyzing agent to be added, so that borneol will be generated. Generated borneol to be added with any kind of dehydrogenating agent, so that subsequently hydroxy will be turned into ketonic group. Hydroxy compound is the borneol. Camphor is the ketonic compound. This is the bicyclic monoterpenoid. Bicyclic monoterpenoid, that is the camphor. This is the way entire biosynthetic route map is provided for the camphor synthesis. Now, we entered into another segment that is called a lab scale preparation of this camphor. How can we synthesize same camphor in the laboratory? For that purpose, very few steps are involved in that. Camphor can be prepared in the laboratory by oxidation of borneol or isoborneol. Can you find any difference between borneol and isoborneol? Only the difference is position of hydroxy. In one condition, hydroxy is in equatorial, in other condition, hydroxy is in the axial position. This is a kind of stereochemistry. Stereochemistry is nothing but orientation of the functional groups. Both are isomers with respect to hydroxy orientation, right? Either of the compound, borneol or isoborneol, are taken as the starting materials, and they are treated with a suitable oxidizing agent. Whenever oxidizing agent is added, hydroxyborneol is turned into ketonic camphor. This process mimics the last step of the biosynthetic pathway of camphor synthesis. In the biosynthesis also, borneol was the last but one step, right? So borneol further treated with any oxidizing agent, so that within the living organism, enzymes will work like oxidizing agents. But in the laboratory, we have to add the oxidizing agent. That is only the difference, right? Here, borneol oxidized into camphor. Here is the typical procedure for the lab scale preparation. In order to synthesize, we need these many chemicals. Let me explain in detail. Borneol or isoborneol should be taken. So both are represented. Both are bicyclic compounds only. And here you can find gem dimethyl. Here we have a bridgehead methyl. Bridgehead, this is called bridgehead carbon. And upon this bridgehead carbon, we have a methyl, right? Borneol, isoborneol, only the distinctive change is orientation of the hydroxy. here, after this starting material, oxidizing agent is required, either sodium or potassium dichromate or else potassium permanganate can be taken. Both are oxidizing agents only, either of the thing we can choose based on the availability. Potassium dichromate or else potassium permanganate to be chosen for the oxidation process. Dilute sulfuric acid is required. It is the kind of catalyst. Dilute sulfuric acid to be taken as a catalytic agent. Distilled water, it's a kind of solvent, we can say. Ice bath is required in order to quench the reaction. If you are boiling, any reaction is supposed to be boiled to higher temperature in order to fasten the rate of reaction, right? So after heating that, reactants turned into products, right? After getting the products, in order to stop the reaction at that instance, that to be quenched, that to be stopped by pouring the reaction mixture into the ice bath. That's the purpose we are using ice bath. And a round bottom flask is required for refluxing or else boiling, and a condenser to be fitted over in order to avoid the in order to avoid the loss of chemical materials, because everybody aware, whenever organic compounds are boiled at the certain instance, all the compounds will be evaporated and they get disappeared from this system, so that though reaction completed but no product left in that flask. Why? Because entire products got evaporated at the higher temperature. In order to avoid the product loss, that to be fitted with the condenser. Condenser used to circulate the water, or else condenser used to circulate the air, so that whatever evaporated products are there, evaporated reactants are there, again they get condensed, again they get reverted into the flask, so that we can achieve the higher product yield. Percentage of yield will be enhanced by using these condensers. Right. Next requirement will be condenser. Just now we discussed about that one, separatory funnel. The purpose of separatory funnel is whenever two compounds are generated. One is the organic compound, and another is the aqueous compound. Let me say one water layer is there, one oil layer is there. How can we separate? So that mixture to be poured into the separating funnel, so that distinctive layers we can notice. Low density material will be always floating on the surface, and high density material will be dropped into the bottom. That is the way liquids can be separated according to their density, right? Obviously, organic compounds are of low density, aqueous compounds are of high density. That's the reason why organic compounds will be occupying the top layer, and aqueous layer is occupying the bottom layer, so that we can open the knob for that separating funnel. Aqueous layer will be drained up, and you can collect the organic layer, that is the compound whatever we have, that to be taken into the another flask. This is the way separating funnel used to separate the mixture of liquids. Rotary evaporator. Rotary evaporator or else a simple distillation setup is required. This is for what? It is the kind of purification. Whenever rotary evaporator or else a distillation flask, in that after getting the product, after getting that camphor, for example, let me put in this rotary evaporator. Uh, because within the rotary evaporator, the mixture of product is there, or else mixture of product is there, along with that some extent of borneol is also there. For example, let me say camphor is there, 70% camphor is there, and remaining 30% borneol starting material left in there, for example. Okay, how it works? Whenever we are rising the temperature according to the boiling point. Camphor boils at the temperature 177. At that 177, you can collect the fraction of that camphor. Later on, borneol will separate in another temperature. In this manner, fractions or distillates get separated by means of their boiling point values. This is the way we can clearly separate the pure product by means of distillation flask or else a rotary evaporator, whatever the kind it might be. These many requirements we have in order to synthesize the camphor within the laboratory. Now, let's go with the process of synthesis setup. Assemble or reflex apparatus, round bottom flask and the condenser. Round bottom flask and the condenser to be fitted over there. Use a water or ice bath to control the temperature during the reaction. At the same time, while heating, the reactants will be heated and the temperature will be raised. In order to control the temperature in the another segment, another flask, you can take another container. We can take ice bath as well, right? That is to control the temperature. Dissolve the oxidizing agent. What oxidizing agent we are consuming? Either sodium dichromate or else potassium permanganate to be taken. They should be dissolved in a dilute sulfuric acid. The purpose of dilute sulfuric acid is either catalyst and solvent as well, not either. It is the catalyst and solvent as well. So that it used to dissolve this oxidizing agent and used to enhance the rate of oxidation process as well. Right, so that oxidizing agent preparation completed. Let me go with another step called addition of borneol. Add a weighed amount of borneol, stoichiometric ratio of borneol to be taken. Instead of borneol, you may choose isoborneol as well. Borneol, isoborneol, both are isomeric in nature, and that to be taken in the weighed quantity, quantified amount of borneol or isoborneol to be mixed up in the round bottom flask, where already we had a oxidizing agent in that. Introduce oxidizing solution dropwise with the constant stirring, and the temperature to be maintained 50 degrees centigrade. Here, whenever mixing is possible, in order to maintain 50 degrees, ice bath is very suitable device where you can constantly maintain the temperature, right? At the temperature, you can mix up this kind of borneol and oxidizing agent as well, right? So whenever ice bath is placed, that used to quench the reaction actually. But whenever high temperature, so the clarity I would like to give here. So actually, ice bath used to give the temperature near zero or else less than zero also possible. Right. Whenever reaction mixture is in very hot condition, for example, 100 degrees centigrade we have. In order to reduce that temperature, for some time you can place that round bottom flask in the ice bath. So by using thermometer, you can continuously measure its temperature. After reaching 50 degrees, you can remove that flask from the ice bath and that to be placed on the heating mantle. Right. Now, the next step is about reflux. So, how the refluxing is possible? Reflex mantle is available with you, and in that the round bottom flask will be placed, and that to be fitted with the condenser. Already you're aware about how to reflex the reaction mixture, right? Condenser to be fitted, and it should be clamped with the stand. For 1 to 2 hours, the reflexing of reaction mixture is possible, ensuring that the entire oxidation process of borneol into the camphor is possible. Only the step we are operating in the laboratory is converting borneol into camphor. That is only the oxidation process, right? So from time to time, you can put up a drop of reaction mixture onto the TLC plate in order to measure the progress of the reaction, whether the reaction moving towards the camphor formation and whether the reaction is completed or else starting materials only left. That in order to identify the progress of the reaction, thin layer chromatography is the most suitable device. Later on, cool and isolate the product. After the completion of the reaction, that to be cooled, because whenever we are heating continuously, reaction is proceeded and oxidation process get carried, right? Later on, cooling is required in order to stop the reaction at that instance, because reaction completed. We need to stop the reaction there. So that cooling is required, crushed ice to be taken. So then that mixture to be poured into the separating funnel. That separating funnel is used to separate organic layer and aqueous layer, as already be aware that top layer will be organic, bottom layer will be aqueous. That separating funnel required to separate this product, camphor, from water or as aqueous components. Extract the organic layer with a suitable solvent. Either ether or chloroform can be taken, right? That to be used, that to be separation is possible by Buckner funnel. Wash and dry. Wash the organic extract with water and saturated sodium bicarbonate to be added in order to neutralize the reaction is existing, because we used dilute sulfuric acid as a solvent, right? In order to make the neutral form, that requirement is sodium bicarbonate. It is a mild base. In order to neutralize the reaction, right? So whatever remaining acid is there, that to be neutralized, so that the crystals of camphor will be separated. Dry the organic layer over the anhydrous sodium sulfate. Sodium sulfate is a dehydrating agent that used to absorb if any moisture is present in that. If any moisture retained by the camphor to be removed, dehydrating agent it will be, so that organic layer to be added with sodium sulfate, so that water moisture content will be removed. Uh, the entire process carried in this laboratory synthesis is only one step, that is borneol, to be added with either potassium dichromate or potassium paramanganate, so that simply hydroxy will be transformed into ketonic functional group. That is called a camphor. Camphor is a kind of a bicyclic bridgehead monoterpene with the ketonic functional group. Gem dimethyl and a bridgehead methyl is also present in that. C10H16O is the chemical composition of this camphor. This is the way laboratory scale synthesis is possible. By this, we entirely completed the session where we covered with what actually camphor is, what source of this camphor in the nature, and what is the biosynthetic pathway, how the synthesis of camphor possible within the camphor tree, and what kind of key applications we can notice for this camphor in the various segments. Later on, is it possible to synthesize the same material on the laboratory pathway? These things got covered in the session. Hopefully, this is very informative. And thank you very much for your patient listening. The session was conducted by Dr. Kavita Kottireddy Kota. Thank you. Thank you, one and all.